Hey guys, for Science on Wednesday, I had a creepy video going here. It's just got kind of cool sounds in the back of wind. But what this is, it's a video. It's entitled, I believe, 10 years of Earth's weather from space in 9 minutes. And it started with 2003 and obviously probably going to go to 2013. But it shows from a satellite image all the wind and all the patterns and everything going on here. You see where hurricanes come in this way. The prevailing winds going this way on the top, this way on the bottom. Just really cool. And today we're going to be talking about wind. So I'm going to get that on the screen now. Make sure you get your science notes out, ready to go. Okay. So first of all, wind. Wind deals with rotation. And if you think about it, the Earth, we have that heating where, let's say the sun's over here, it heats the surface, the warm air rises, and then rises up, cools, and sinks. Rises up away from the surface, cools, and sinks. And it does that all over the place. And then you add the rotation of the Earth with it, and you get this, what's called the Coriolis effect, this stuff going on here. That's a pretty good look too. If the Earth was maybe where this triangle, or the sun was where this triangle was, beating on the Earth, the warm air rises and then cools and then gets that cycle going, and then you spin the Earth with it. It creates quite the effect. So, warm, moist, light air at the equator rises and heads to the poles. So it rises and heads that way. Cold, dry, dense air at the poles head towards the equator. So this drops and then starts coming that way. Okay? Advantages of satellite images, well, you can get big, large areas there. There's some that are stationary and some that are not, that move around with the Earth. But it's a really cool look here. This little link was to that video I just showed you. It's a pretty cool watch if you want to do it. We move on to measuring relative humidity. We're not going to stop there, maybe later when you get back. Lesson 4 though, how are weather forecasts made? What we study are big air masses. And in these air masses, let me move this back a little bit, we can have only 2 or 3 cover the entire United States. In this case, you got a big cold air mass coming down, a big warm air mass coming here. There's probably another one over this direction. It says they're a very large body of air that has similar properties of weather conditions throughout. Meaning, if you had a big cold air mass, you wouldn't have like a little hot one here, a little hot spot there, a hot spot there. It would be cold throughout the whole thing. Warm throughout the whole thing. Usually warm and wet, cold and dry. 2 or 3 can cover the entire United States. Meteorologists try to predict their movement. Now it's where they meet, where you cause things what we call a front. And when you get warm, moist, hitting cold, dry, then you get weather along those fronts. That boundary is called the front. Between the air masses, a cold front is cold air mass moving into a warm air mass. So if this one was on the move, that would be a cold air front. And this one would win because it's heavier, denser. It'd start pushing that warm, moist air out of the way. A warm front is when a warm air mass moves into a cold air mass. So if the warm air mass is moving a little faster, with a little more authority here, it could start bumping the cold mass away, but it would more or less ride over top of it. A cold air mass could bully a warm air mass more than a warm air mass could bully a cold air mass, but they can push each other. Okay? And along those fronts is where you're going to find the weather. So when you're predicting weather, like a meteorologist, that's where you'll focus. And here's a sideways view of a front. This cold to warm is referring to this picture. Warm to cold is referring to that picture. So let's talk about cold to warm. So the cold air moving this way, it's heavier, it's denser, it's going to force that warm air up quickly because it's the bully. It moves it up fast, and that's where you get a thunderstorm, possibly. Okay, warm to cold. The warm air rides over cold air gradually. Precipitation may occur. So you got warm, moist air, and it hits that cold, and it kind of moves it a little bit, and you get rain, but you're not going to get the thunderstorm because it won't go up quickly. It has to go up quickly to have other cold air come down quickly, and then you get that rubbing effect to create static electricity and storms. Okay? In general, weather moves from west to east. If you can see this, you got Linden, Washington here. This is the west coast. Weather in the United States usually goes this direction. Okay? Make sure you're caught up with your notes. Make sure you ask me any questions you have when we have our Zoom or our Google Meet. 3 major clues in predicting weather are studying the air mass, understanding fronts, and then air pressure systems. And this picture here shows a cold air mass. It shows a warm, moist air mass. Dry, probably warm down here. And where they hit is the front. This doesn't have a big H or a big L to show a high or a low, but those would be the 3 things. The air masses, the fronts, and then the highs and the lows. The highs are going to have good weather. The lows usually invite weather to them. Now there's quite a few notes on this paper, or on this slide, so let's keep up here. Technology and weather. So we have something called the National Weather Service in the United States, and around the country we have these sensors. Now at the time of the book they said 900, they've probably got triple that by now. Where do they find these sensors for studying air mass and air pressure and the fronts and all that data? A lot of times airports and big cities and so on. And there's also, I know there's one station out off the Enterprise Road, if you ever see it, it's a white thing with a big centerpiece sticking out of it, it's in a circle. They gather data, they send it all to the National Weather Service, and every minute they're sending it to there, and they have these big computers that go through, they collect all the information, then they interpret it. Okay, they all work together to provide warnings. We have something called the AWIPS, all right, and that's shared all around the world. It's if you've got weather that's going on in Bangladesh and Moscow and London and New York, they're all interconnected, and they do affect each other throughout the world. Okay, how it all works? Well, sending those weather balloons up is great. Ships can also have sensors, airplanes, buoys. You got buoys sticking out in the middle of the ocean. Satellites, all working together. And they use computers to send it all to the National Weather Service. Computers go through the calculations and interpret it. Then you have weather reports that are issued. A lot of times they just come out on your phone now. We can have it go out this way: airports, radio, TV, newspapers, military, internet. Phone is probably where most people are getting their news on the weather nowadays. There you got the symbols for the National Weather Service, and then NOAA, which is the National Oceanic and Atmospheric Association. What we're going to do is we're going to stop right there for today and make sure that you're up to date on your notes.